Hello everyone. Uh, Today we will discuss a common problem, which is the catch the lazy thief. It's obviously named different, but a little interesting, but the core concept lies the same. So let's have a look at the question. So there was a thief who robbed a bank one night, and he went to a street with 5 houses in a line. Now police got to know from the sources that the thief is hidden in one of the houses on that street. But due to some law restrictions, they could only check one house each day. Now, knowing this, the thief moved and hid in one of the adjacent house every night. And why only adjacent? Well, he was a lazy thief, right? Yeah. So now the police need to capture the thief in under 1 week because of media pressure, and they hire you to help them. So, what strategy would you suggest them to catch the thief? Is the question. Now, let's pause the video here and take some time to think upon this problem and see what how we can approach this problem in a systematic way and how we can solve it. Try to think on those areas. We will discuss the solution and basically the approach, because for me that is more important. We will discuss that in a few seconds. Okay, now go ahead. Okay. Uh, So welcome back. I hope you give some thought to this question. Now let's try and see how we can approach this problem to solve it. Now, one of the very basic problem solving techniques is to break the problem into sub problems, right? So that's what we're gonna do today. So let's number the houses 1 to 5. This is how it would look like in a straight line, right? Um, Sure. And now the sub problems could be the thief could be in an odd numbered house, or it could be in an even numbered house, right? So we can solve both the cases separately and see how we can connect them into a solution. So that would help us to solve the problem, right? And another point that we observe here is that whenever thief moves to an adjacent house, he is moving from an even number to an odd numbered house, or from an odd numbered house to an even number house. So if he's at 1, he would move to 2, so it changes from odd to even. But if he's at 2, he can move either to 1 or 3. Both the cases are odd, right? So let's use that to solve the problem. Okay, now how do we actually catch the thief? How do we close in on the thief? Because the thief can move in any specific direction. We might not be able to catch the thief until we know how exactly do we catch the thief. So how do we catch the thief? If the thief is one of the corner houses, for example 1 or 5, then we know that thief has only one option to move. If he is at 1, he can only go to 2. If he is at 5, he can only go to the number 4 house. Now by knowing this, we can close in on thief such that if we know that thief is at 1, after some checkings, we can know that the next day we would find the thief at number 2, and maybe we can catch the thief. So that's how we're going to close in on the thief in this problem. Okay, now let's see how we can approach this. Now firstly, let's try to solve it for an even numbered house. Okay, now when we say even numbered house, we say 2 or 4. Now we are assuming here that the thief is either in house number 2 or in house number 4, any one of these, right? So by the assumption, let's just go and check the second numbered house on day 1. Now if you find the house, well, it's good enough for us, but we're going to consider the worst case every time. And let's see. So if I checked house number 2 and if he is not there, then it would mean that the thief was in house number 4 according to our assumption. Now if he was at 4, he would have either moved to house number 3 or house number 5, right? Now again we have 2 houses to check. Let's go and check house number 3 on day 2. Right, if we are not able to find the thief on house number 3, that means the thief moved from 4 to 5 and he did not choose a path from 4 to 3, right? So at this point of time, when we are checking house number 3, we exactly know that thief would be at house number 5. Now all this is based on the initial assumption that the thief started off from an even number house, right? And the next day we can just go to house number 4 because there is only one option to move from house number 5, which is house number 4. So if we go and check the house number 4 on day 3, we would be able to catch the thief. So in 3 days we would be able to catch the thief if the thief started off from an even numbered house. So that was the assumption, and we would be able to catch the thief in 3 days. Now what about the case when the thief was in an odd number house? Right, so if we observe this thing, if the thief started off with an odd number house and we anyway checked for an even combination, that is, if we assumed that the thief was in even number house, we check the 3 days, 2, 3 and 4, we take 3 days to check this. But even after 3 days we are not able to find the thief. It obviously means that the thief was in an odd numbered house, right? But what happens after 3 days? The thief would have moved from odd to even to odd, and then from odd to even. So right now, after 3 days, if I'm still not able to find the thief, it means that the thief is now in an even numbered house, right? If the thief started off with an odd numbered house, after three moves, he would end up in an even numbered house. And now if we know that the thief is in a even numbered house, we can just repeat the same process. Let's go check 2, then 3, then 4, and we would be able to catch the thief in 3 more days. So that's how we can follow a simple solution, assuming one of the sub problems in finding a solution to another sub problem, connecting them, solving a complete solution. So if we go and check the houses in this manner, 2, 3, 4, 2, 3, 4, we would be able to find the house. We can obviously find the house much before if we're lucky, but this would be the worst case scenario. There obviously can be other solutions as well, but the core concept remains same. For example, if you want to check number 4 first, you can check 4, then 3, then 2. That's what you can do, or you can do 4, 3, 2, then 2, 3, 4. That's up to you. So there are different solutions, but the concept remains the same. So I hope you were able to understand a concept here, not just look at the solution for this problem, but you were able to see how we can approach a particular problem and solve it. Now, this is a common technique which can be used in multiple puzzles, and I hope I post more such puzzles where you can apply this and solve it. Alright, so thank you so much for watching this video. I hope I was able to provide some value here. Keep solving, and do subscribe if you want to listen to solve how to solve both puzzles. Thank you.